So angle similarity of triangles. This goes with 11.4 in your text. And your essential question today is, how can you show that two triangles are similar? All right, and you have a learning goal, which is I can prove two triangles are similar using AA criteria. Vocabulary for today, the word similar. So when we're talking about triangles that are similar, it's when their corresponding sides are proportional and their corresponding angles are congruent. And so we talked about two triangles when they're congruent. That's when they have exactly the same size and shape. If two triangles are similar, then they have the same shape, but different sizes maybe. And when they're similar, it turns out that their corresponding side lengths are in proportion to one another. So we'll actually be able to solve problems with missing side lengths where we can set up proportions and then do some algebra and figure it out. Okay. And so this right here, angle, triangle similarity theorem, this is the main idea here. This is the theorem that we're learning about, AA. If two angles of one triangle are congruent to two angles of another triangle, well, then that's enough information for us to say those two triangles are similar. Up here in the definition of similar, it says that their corresponding angles are congruent, which means all three angles on one triangle are the same measure as all three angles on the other triangle. And so by this theorem, though, it says that we actually only have to know that there's only two pairs of angles that are the same measure. Because if you have two pairs that are the same, then that third other pair of angles has to also be the same measure. And so from that, we can then conclude that they are similar. Okay, so the reason this is useful is that architects and contractors use properties of similar figures to find any unknown dimensions, like the proper height of a triangular roof. They can use the bevel angle tool to check that the angles of construction are congruent to the angles in their plans. All right, so we're going to look at an example here where we're going to find indicated length if possible. And so the length that we want to find is BE. And then if you look at the picture over here, BE is this side right here of this triangle. And these two triangles that are created, we want to figure out, are they similar? We have to do that first. So first determine whether triangle ABC, okay, ABC, is it similar? This little squiggle, that's the notation for similar to triangle DBE. DBE. And so we have to determine if they're similar, and then if they are similar, we can use a proportion to solve for a missing side length, BE. Okay, so it says here by the alternate interior angles theorem. So this is something we learned about earlier in our school year, alternate interior angles theorem. This side length right here, AC, and this side length, ED. Do you see these little arrows right here that are like in the middle? What this means is that these are two lines that are parallel to each other. And so when you have a pair of parallel lines, then alternate interior angles become congruent, which means angle A is congruent to angle D. So right here, this angle A is congruent to this angle here. Those are alternate interior angles. And also angle C is congruent to angle E. So angle C and angle E, that is another pair of alternate interior angles that are congruent. So right there, we now know we have two pairs of congruent angles. That is enough information for us to say that by the angle triangle similarity theorem, the two triangles we're comparing are in fact similar. So if we know those triangles are similar, then we can set up a proportion to solve for this missing side length of BE. And there's more than one way to set up a proportion, all right? You just have to make sure that you're putting things that you're comparing in the right spot. So one way to do that is they put BD over BA. So side length BD is right here. This is the side length of 54. Okay, that's proportional to side length BA, which is 36. And then, so that ratio is equal to the other ratio, BE, which is what we're trying to find, is proportional to BC, 54. All right, so if you set it up the right way and plug in the values you do know, you can then solve this, okay? Your variable that you're solving for is BE. It's two letters together, but it's representing your unknown side. To solve a proportion, you would then just multiply both sides by 54 and simplify, and we'll find out that the side length BE is 81. Okay, so this is an application of a triangle similarity theorem. On the next slide, we're gonna, again, find the indicated length if possible. All right, and so what we're gonna do with this slide here, this is one of the ones you write on. Okay, so I would like you to follow along with me. We're gonna do this together. Let's see, so I am gonna switch over to this one so I'm able to write on it. All right, so RT, this is what we're trying to find. And so I'm going to just use the different drawing tools here. When you start out, you can use the line tool. And the size that it starts, it's always kind of pretty thick. So I like to change it. I'm going to pick some random color here. And so we want to find the side length RT, which on the triangle here, I'll mark it, is that one. Okay, so this is what we're trying to figure out if we can even find its length. So your steps, you have to first check if, in fact, the two triangles in the picture that you're given, are they similar? Okay, and so we're talking about triangle RSV, RSV. So this is the smaller one that is inside. Is that similar to triangle RTU, the larger triangle? Okay. The smaller one is completely contained within the larger one. So they are similar. I'm sorry. So we're trying to check if it's similar. It says it is given in the diagram that, so some angle is congruent to some other angle. So what is given in the diagram? If we look over at our diagram, I'm going to grab the pencil tool here and see that there are a pair of congruent angles, in fact, and they're marked like this. So what we want to do is fill in these boxes right here with the information that represents those two angle measures. And I'm going to kind of just check and see what you guys are writing on your slides. So I have 9 of you that have already started doing this. We have S and T. So T is definitely correct, right? Here's T. I can't confuse angle T with anything except T right here. But angle S, I'm going to have to be a little more specific for angle S because what part of S? Like we're going to want to use three letters to represent the angle that I'm talking about for S. So if you have S and T, you're off to a good start. But for S, we want to actually use 3 letters to represent what that is. T is correct. T is correct. So let me go ahead and show you. Text tool. Right here, we have angle T. And then this angle here, this is the larger box. So I'm going to put in 3 letters to represent the angle that is marked with that little single green arc mark. So you can either write RSV or you could write VSR. Okay, so that's what you want to fill in for those two boxes there. It's given in the diagram that those two angles are in fact congruent. And also, we can tell that angle R is congruent to angle R. We're saying that angle R is congruent to itself. So this is another property of congruence, right? Which, go ahead and draw that in. So we're talking about, this angle right here, angle R. I'm going to put a double arc mark there. I know that angle R is congruent to itself right here because of what property of congruence? So there's a name for this. See if anyone remembers what it's called. Yes, good job. This person got it. Reflexive. Yes, very nice. It's the reflexive property of congruence. And so that's what we're going to type right here. And so let's drag that up here. And I'm going to just erase that. Oh, no, it looks messy. I don't like it. All right, so we have now shown that we have two pairs of congruent angles. The two that are marked with green on my paper or my screen, that's a pair of congruent angles, and then also the double arc mark, that's a pair of congruent angles. R is congruent to itself. And so once you know you have two pairs of congruent angles, now we can use a theorem, okay, to say the triangles are in fact similar. And that theorem, let's try and paste here, is right back here on the vocabulary slide, okay? That is the angle triangle similarity theorem. And so we're going to type that in. We're going to put by a triangle similarity theorem. Alrighty. So we've now done right here. We've done this. We've checked that the two triangles are in fact similar. That was what all this was, okay? And now, because they are similar, we're going to be able to find RT. So side length RT is right here. And this is one way to set up a proportion. RT over RS, so that's one of your ratios. So RT over RS. So it's this entire side length of the larger triangle compared to the smaller side length of the one that's similar to it, RS. And then TU, so TU is from here. That's the far right side of the largest triangle. TU is to the far right side of the smaller triangle, SV, right? So we're just going to fill in these boxes with the correct numbers to match what we see here. So RT over RS. RS is a side length of 10. Oops. And then for our other ratio, we're going to fill in those two numbers there. So let's see what you guys are coming up with. So let's see, are we going to write 12 over 8 or 8 over 12? 12 over 8. So what we're going to do is actually replace the letters now with their numbers. 12 over 8. That's correct. I'm going to put 12 over 8 because TU is the far right, larger triangle side length, 12, and then SV is the smaller far right triangle side length of 8. So 12 over 8. All right, and now we want to solve this. We want to solve this proportion. We want to solve and get an actual value for RT. And so let's see, we are going to some other random color here. So to get RT isolated, right now it's being divided by 10. So we're going to do the opposite. We're going to multiply by 10. Right? You can think of multiplying it as 10 over 1. So that way those cancel. We'll get RT isolated, 1 RT. But whatever we do to the left, we'll do to the right side over here. So we're going to multiply both sides by 10 over 1. And when you multiply fractions, you can either simplify out common factors before you multiply, or you could do it all at the end. Doesn't really matter, but you need to multiply your numerators. Okay, so 12 times 10 is 120. And then 8 times 1, multiply your denominators across. And if I simplify, 120 divided by 8, that should go in that evenly. You can use a calculator if you want to. Let me see what you guys are coming up with. 120 divided by 8. Okay, so this person figured it out. We actually get 15. 15 is the side length RT. This person got 2, 15. All right, so length of RT is 15. Okay, so that's this entire length of RT. And I mean, this answer does make sense, right? Because if you look up at the picture, the side length RS is only 10. And then, so this entire side length should be more than 10. This is more than 10. You should always check the validity of your answer to make sure, it just makes sense. Like if I ended up with a number smaller than 10 for the side length of RT, that's like a red flag that, hey, you probably made a mistake, that your longer side length is actually not longer. All right. Okay. So, I'm going to come back over to this one. And so we are now taking a look at the next slide, slide 5. Right, and this is a discussion problem. So let me do this. So once you're done copying down whatever it is you're copying from the last slide, you're going to go to the next slide, which is slide 5. And it says here, when asked to solve for y, a student sets up the proportion as shown. Explain why the proportion is wrong. So they made a mistake. And then how would you adjust the proportion so that it will give the correct result? So they looked at this problem and they decided, all right, these are two similar triangles for the same reason that we had two similar triangles on the last slide. They share angle, the measure of angle A and the measure of angle DCE or angle ECD. You could read it either way. They're congruent angles and they have the same measure. Also, angle E turns out to be congruent to itself. So again, by the reflexive property, we now have two pairs of congruent angles. So those are similar triangles. And so they're setting up this proportion. They say y is to 8 as 14 is to 10. But there's an error in how they set up the proportion. Okay, one of those pieces is incorrect. So what piece is wrong? And what would you change it to so that it makes sense? I have 2 responses so far. So I'm going to give you a couple minutes on this one just to get caught up with this slide and to also try to answer this one. Alexa, play. So I see a lot of us are in the meet right now. You should be answering slide 5. Okay. So I think I'm just going to push everyone over and make you all be on slide 5 real quick. And put in what you think is wrong with that proportion. There's something wrong. Alexa, pause. Okay, so I only got 4 of you to respond to this. Says the proportion is wrong because of the size comparison. It should be y and 14 compared to 8 and 10. Y and 8 can't be set up like that. I think it should be AC. AC, okay. A equals 14 because the smaller number would be on top. So the issue with this one is that, let me just maximize this. So clearly some confusion here. So let's just say that the proportion, as far as the right-hand side, that is correct. 14 to 10, right? That's okay. So we have 14, this larger triangle, the top side is 14, and we're comparing it to the smaller triangle, the same corresponding side of 10, so 14 over 10. And then the left-hand side of our proportion for 8, that is the denominator. Okay, so we have the smaller triangle side length that's over on the left in the denominator, just like we have the smaller triangle side length on top in the denominator. So that's okay. So everything is okay except for y. Y can't be here. So y should not be there. Y is incorrect. And we should change it to should we change y to? So if you look at the numerators, 14 is the top side length of the biggest triangle. And we want to compare it to the side length all the way to the left of the largest triangle. So that's basically side AE. All right. And I think somebody said AE. And come back and share some responses here. AE. Okay, so they did decide it was AE. I'm not really sure if it's 14. I don't think it is 14. It's not 14. Proportion will be AE, AE. Now, what can I represent AE as? So I'm going to change it to AE, which is the same as what two things could I add together to represent the entire length of AE? I'm going to add two things together. Y plus 8. Y plus 8. Right? Because if you take the piece AC and the piece CE, we know that the small section is Y, the other section is 8. We add those two sections together, then we get Y plus 8. So you can change the way this is set up so that your numerator right here is actually Y plus 8, and that would represent the entire side length there. Okay, so we're going to move on together. We're going to look at this next slide here. We are going to prove, we're going to do a two-column proof. This is actually our learning goal for today. If you remember, we come back right here. Your learning goal says, I can prove two triangles are similar using AA criteria. And so we're going to actually do that right now. So here is a picture. And in this picture, we're going to, you'll notice there's two triangles. There's triangle ABC, ABC, and triangle EDC, EDC, okay? We want to prove that triangle ABC is similar, okay? Remember, this is a similar symbol to triangle EDC. And so we have some statements that we're claiming here, and then we're going to fill in the reasons why for each of these statements. So the first statement says, well, angle A is congruent to angle E. And the reason that I know angle A is congruent to angle E is because why? How do I know that? So what is this first reason here? What could I put there? We're actually just going to type a word right here under reasons. And I'm kind of curious if you guys remember, because you have done problems like this before. Aha, this is what I'm looking for. So this person got it. The reason that we can say angle A is congruent to angle E is because in the picture it is given, all right? It tells us that. We can see there is a single arc mark on angle A and a single arc mark on angle E. So it is given. That's what you'll type in the first box, given. And moving on now to the second box, okay? Angle ACB. Angle ACB. So we're talking about right here. I know it's a little hard to see. I'm going to put something on there to make it stand out. So let me come over here. I'm going to use my pencil tool. And I'm going to put a little teeny. Yellow is not a very good choice. Pick a different color. maybe red. Okay, so I'm going to put a double arc mark right there. So we're saying angle ACB is congruent to angle ECD. ECD, that's this one. Why do I know that these two angles are congruent? How can I say that's true? There's a reason why. So you got to fill in the reason. How do I know? I think I want to, here we go. I'm just going to do some color coding. So the first thing here, angle A is congruent to angle E. It's given. Those are the green ones. And then now I'm on to saying that the two angles that are marked with the double arc marks are congruent. How do I know that? Let's see if someone came up with it. This is very good. Vertical angle theorem, vertical angle theorem. They're vertical angles. Vertical angles are always congruent because of the vertical angle theorem. So that's what we're going to type in. So a couple of you got that. You figured it out. And so we're going to just type right here, vertical angle theorem. Vertical angle theorem. And then we have one more thing to fill in. So we've now shown that there are two pairs of congruent angles, right? Angle A and E, and angle ACB and ECD. And they're marked in my picture. Once you have two pairs of congruent angles, well, how is it that we know the two triangles are similar? You're looking at it right now. If you're, doesn't matter what screen you're on, if you're on the presentation screen or if you're on the Meet screen, all right, right there. It's the theorem that we're learning about today, okay? And so the last thing you're gonna type in is angle similarity theorem. I appreciate this. Someone else did this in my last class too. VAT for vertical angle theorem. That's not a recognized acronym that I'm aware of, but I appreciate creativity. Okay, so we're going to go ahead and let's see, I'll type in green, I think. So AA, triangle similarity theorem. Okay, so there we go. We proved it. We took a picture with two triangles, and we were able to prove that those two triangles are similar by first identifying two pairs of angles that are congruent and then saying, hey, well, that is the AA triangle similarity theorem. They're congruent. All right. Let's go to the next slide. What time are we out of here? Let me check that, because I don't want to be taking up too much time. I lose track of time. 11:40. Aha, 4 minutes. Okay. So anyhow, thank you for coming off your mic and telling me that. This last slide, there's two more slides. You can read through these two examples. Okay, they're just more examples of how you can apply triangle similarity theorem. When you see, okay, so the first pair of triangles that we're saying are similar. Remember, when you see these arrows like this, it means these are two lines that are parallel. And then we have corresponding angles theorem, reflexive property of congruence, and then finally AA triangle similarity theorem. Okay, and then you have the second example down here. They're saying you have a pair of right angles and then a pair of marked angles that's given that they're similar. And so again, you have two pairs of, once you have two congruent pairs, then you just use the angle-angle triangle similarity theorem, right? And so you can set up a proportion. It shows you how to set up a couple different proportions and then solve for the missing side length. You can do that.